has been done for a long, long time, but there's been some history around that. Right now, it's 2018, but previously, we used to do caching in a different way. And I'm going to show you how we used to cache and what the new ways and the modern ways of caching are. And some of the pitfalls, some of the caching strategies, I'm going to explain a lot of that. So first introduction, what is caching? How do we do caching? Why do we do caching? And then I'm going to talk about caching before PSRs came along, before the PHP FIG started to get involved in caching. And then I'm going to talk about PSR-6, which is the sixth standard recommendation of the PHP FIG. And that is also called the caching PSR. And then I'm going to talk about PSR-16, which came a little bit later. And that is dubbed the simple cache interface. So, let's get started. What is caching? Caching is basically speeding up your application by avoiding to repeat slow processes. So slow tasks can be cached if the output is the same for the same input. So for example, we can do a slow query on the database, and we can cache that. If the input variables are the same and the output variables and the output is the same, then we can cache the output to avoid having to do the slow query over and over again. Or executing a slow task. For example, generating a PDF or a zip file. So the three steps are checking the cache, if we already have the cache value stored. If not, we have to execute the slow task, do the PDF generation, do the zip file generation, do the aggregation query on the database. And then, in the end, we store the result and we continue the process of our request handling with the remembered result. So, rule number one of caching is, if your caching layer fails, your app should not fail. Of course, that is not including like memory stuff or load stuff. If your load is too high and your caching is failing, it's possible that your app is failing. That's okay. Well, it's not okay, but if your caching layer fails, your app should still work in every single way. So locally, on local development, if we disable cache, our app should still work. I'll repeat this every few slides. So a couple of examples are doing a slow HTTP request. If we have to download, for example, a packagist zip file, some kind of library. Composer caches external libraries, for example. Or a slow database call, if you have to do a lot of aggregations and the database can't quite keep up with all of those aggregations. If you have the same input and the same output, then you can be confident that you can store the result. Another thing you can cache is, for example, generated zip files or generated images or generated PDF files. Those kind of things you can cache as well. So again, rule number one of caching, your app should not fail if your caching fails. So if you cannot connect to Redis or memcached, your app should still work. Right? You should wrap it in some try-catch blocks. Or again, if you're on a local environment, your caching is probably disabled, or it's set to a 0 implementation or a local in-memory implementation. Your app should still work. This is a timeline that shows how the process works. First, you check if the cache has the result. If not, you do the slow process, and then you remember the result, and then you continue. So, for example, geocoding is something that's pretty slow, and typically the same input gives you the same output. So if you want to geocode an IP address and you want to find the location of the user, you can use some external service. But your external service is probably like a couple of milliseconds away, at least 50. And doing a lot of geocoding can basically lengthen the response time of your response if you do not cache it. So if you geocode the same IP address over and over again, you should add some caching layer in between. So the second time you want to geocode the same IP address, you actually hit the cache layer and get the response from there instead of hitting the external service. And then rule number 1, what was rule number 1? Your app should not fail if your caching layer is failing. Caching can happen at different layers of your application. Different layer of your stack can happen on the user agent. So if you have JS files or CSS files, your user agent will typically cache those. So it doesn't retrieve the same minimized or like big JavaScript files or big CSS files. The same thing can happen or can be cached on the web server layer. So Varnish is a very popular caching layer in between your application and your user agent. And then what we will be talking about is on the application level. So what we do, PHP development, is typically application development, whether that's a web application or a CLI application or whatever. That's the application level. So in our code, in PHP code, we are going to add some caching as well. And then there's op cache, and op cache is basically, if you know a thing or two about PHP, PHP has a double pass compilation. So first it compiles opcodes, and then it compiles those opcodes into bytecode. But if the source code didn't change, your opcode will not change. So if your source code is not changing on your production server, your op cache can be enabled to prevent the double pass compilation. So we are only going to store the opcode, and we're going to reuse the opcode over and over again for every incoming request. Rule number 1 of caching: your app should not fail if your caching layer is failing. So there's some strategies for caching, and you can every situation has its own needs. There's some strategies like warming up a cache before users start hitting your application. This helps with ramping up traffic to your site. So if you're a high-load site and you want to bring up a new server, the new server will probably not have any cache values locally. So warming up the local cache so it doesn't have to hit some remote Redis server can help. Or you can also use some CLI tools for that. You can also process some slow tasks in the background, so you don't have to let your users hit some route and then wait a while until the zip file is completed, and then you download the zip file. You can also pre-process that and say, well, this user will probably want to download this, so we are going to pre-generate the zip file. So when the user hits the route, it's going to already, the zip file will be already available and will be downloadable like in a jiffy. Another strategy is to set a really long time to live. So a TTL is a time to live. Typically, this is measured in seconds. What you can do is set a time to live to a very long date in the future, and then whenever the value should change, you can just bust the cache or clear the cache, and then you can regenerate the cache and store that again. Another thing is called stampede. Stampede protection in caching is basically preventing your server from doing the same task over and over again for a lot of incoming requests. I'll explain this later in a future slide. So before 2015, we used to do caching in PHP as well, but it used to be kind of like everyone was rolling their own and everyone was doing their own thing. So libraries would do their own thing. Geocoding libraries would have their own caching layer. They would have connections with Redis and Memcache, but not a file system, for example, or they would not have a void adapter or something. They would have their own interfaces, so you would have to build adapters and stuff. Frameworks have their own caching layer as well, like Symfony, Doctrine, Symfony, Zend, Laravel, they all have their own caching layer. But they're not kind of cooperating. They all have their own way of setting it up. They all have their own setup. And they all have their own set of implemented backends. So some would implement Memcache and Redis, but not something else, like a database adapter. And then there's also caching libraries. There used to be a very famous one. I just forgot the name, but there used to be a very famous caching adapter, a caching library that is like purely focusing on caching. But for frameworks to adopt that, that's a different thing. So frameworks would still roll their own. So between the frameworks and the libraries, there would be a lot of like annoying differences. The support for the caching backends would be different. So when your library, for example, your geocoding library allows Memcache but not Redis, and your frameworks allows Redis but not Memcache, then you would either have to write your own adapter to use the same Redis backend for your geocoding library, or you would have to store values in different backends. But ops people will hate you for that. If you want to set both Redis up, if you want to set up both Redis and Memcache, that's kind of silly, right? You're going to store values in different databases that basically do the same thing. So ops people will hate you if you do that. So there's basically an overload of adapters. There was an overload of adapters between frameworks, libraries, caching libraries. So packages is full of these adapters or bridges, if you will. So if there's no adapter available, you either have to write your own, or you have to store it in a different cache source. But then the PHP Fig said, well, let's do something about that. There's a couple of people in the PHP Fig, like the people from Doctrine, Symfony, I think Laravel left, and some other people, and they said, well, we might want to find some common ground and make an interface that works for all of us. So that's why PSR-6 was initiated, and it was finalized and accepted in December 2015. I think that's almost 3 years ago. And it's built in a repository entity way. So there's a repository which keeps track of all entities, and those entities are the cache items. So per cache key, there's a different item. And if you request the same cache item from the cache pool, then the pool will return the same exact value object. So this is how it's implemented or interfaced. There's a cache item pool interface, and there's a cache item interface. And if you use the pool to get an item with a key, you get the item, and then you can set the value, you can set the TTL, and then you can ask the repository or the cache item pool to save it. The item itself is an entity, so it has an identity with a key, and the key is never changing, but the value and the TTL can change. So it's not an immutable object, but the key of the object is immutable. You cannot change that. The rest you can change. You can change the value, you can change the TTL. The rule, if you want to use this, is you never create your own item objects. You ask the cache item pool to get a new item. Whether that's stored in the backend or not, it doesn't matter. It will return you an item, and then you can set a value, and you can set the TTL, and you can ask the pool to save it. The pool also has support from multiple, like batch operations, so you can get multiple items at the same time. This will return an associative array with the keys. The keys you entered will be the keys of the associative array, and the values of the associated array will be the cache item. The cache items. You can also do something like save deferred. save deferred will store the entity and will say, well, sometime in the future we will save this, but we will stack up multiple items so we can use some efficient strategy to store them all in the backend in one call. So we don't have to do a lot of round trips to the Redis database. And then in the end, you will have to do pool commit. I think if you do pool destruct, if the garbage collector destructs the pool, it will also commit. So yeah, let's look at some code. Vendor, PSR, cache, source. So there's cache item pool interface, which has a couple of methods. Can you read this? Nope, it's too small. Okay. Public function. So there's get item, which obviously returns one item. There's get items, which returns multiple items. And this returns an array, or it's reversible, of cache items keyed by the cache item key. Then there's public function. Then there's has item, and has item will return a boolean. Has the backend got an item stored for this key? Then there's clear, which is basically like truncating the entire backend. And delete item will delete one item by the key. Delete items will delete multiple items by the keys, by the given keys. Save will store one item. It will store that immediately. And save deferred will save it, but not immediately. So if you stack up multiple saves, it might hit the backend at some point. But if you really want to store it right now, you can do commit. And then there's cache item interface. And the cache item interface has public function, public function get key. This basically returns the key. Could be foo, could be whatever, the key you entered. But the key will never change for the same item. So the same item will may have a different value. So the value you can get with the method get, which is pretty obvious. And you can find out if it's actually hit or not. So you can use two ways to find out if a cache item is stored in the backend or not. You can use a cache item pool has, or you can do get item and then is hit on the item itself. And then you can set the value or overwrite the value, and you can set the TTL with expires at, and expires at requires a datetime interface, so a specific timestamp or a specific point in time where it will expire, or you can say expires after, and that takes an interval, like a date interval, or an integer, and the integer is, I think, in minutes? No, in seconds. So the integer is in seconds, and the date interval, you can set it to anything. It said could be days, could be minutes, could be a combination. So that's the interface. It's pretty complex, I would say, but let's see. So why is it so complex? It's basically complex to allow for extensions. You can extend the cache item pool interface to have some extra methods. And those methods don't have to reflect on the item. There's also a couple of characters which are reserved for the key. So the key cannot have like the curly braces, normal braces, forward slash, backslash, @, and colon. Those are reserved for future features that might be spec'd by the PHP fig. So there's some features you can add to these caching interfaces. For example, stampede protection. Stampede protection, I talked about this earlier, but stampede protection basically protects you from doing a slow task over and over again if you have a lot of users hitting your endpoints. So if one endpoint triggers a new slow process that needs to be cached, you might want to say you might want to use a different strategy to prevent that from happening. So this is a timeline, and one user comes in and requests something from a slow database, like a slow database query. It does a slow database query right here. It takes a long time, but when it's finished, it's going to store that into the cache. And it's going to set a TTL, but the TTL is pretty long, and there's a second TTL as well. And the second TTL is like an intermediary TTL. So a lot of users are coming in, and they're hitting the same request, and they're all using the cached store, the cached item value. Now, when the secondary TTL is reached, there's going to be one user which is elected, like the first one to hit this next TTL, the secondary TTL, and that one user is going to start processing this slow database call. And when other users are coming in, they're not going to do the same thing. So in the value, there's going to be some metadata that says, well, someone is already processing this, so you don't have to do this. And they can still use the old value. The old value is still valid until the second TTL at the end of the TTL frame is reached. So someone else is already processing the slow database call and will update the value accordingly. And in the meantime, all other requests are still using the old value. And then when the value is updated, the TTL is pushed back, and the secondary TTL is set again. And then when the traffic dies down, the TTL might be reached, but that's okay because you won't have 10,000 users at the same time. There will always be a ramp up. So when a new user comes in, they will have to do the slow database call again. So that's stampede protection. Another feature you can add to caching or to cache item pool is tagging. And tagging is basically saying, well, this item belongs to this category. And then later on, there's a package right here, and there's someone in the audience who created this. There's a package right here called cache/taggable cache. And taggable cache allows you to do this. You can add tag items to a cache item, and then you can ask the pool to invalidate all items that are tagged with that category, for example. Another feature is hierarchical cache. It's pretty hard to pronounce. And there's a cache / package for that as well by the same author. And it works like this. You can set keys in a hierarchical way with the pipe symbols. So the pipe symbols allow you to make differentiations between different levels of the key. And if you set some item on the sub-level of some key, you can use an upper level or a parent level and say, well, everything below this needs to be purged. So you can say delete users 4711, and then everything that is cached for that user will be purged. So when you set this item, it will return true on the has item. But if you then remove everything for that user, which is on a higher level, this is a higher level key, then everything below that key will be purged. Cool. So that's all neat and all, but who's using it and how can I start using it? So if we go to packages.org and we type in PSR/cache, we find that there's also a cache implementation package. And the cache implementation package is a virtual package, and it doesn't have any stars or downloads. It's a virtual package. You cannot install this. It's basically like an interface. You cannot new up an interface. It's not concrete. So you need a concrete implementation of this. And if you click on the Psr Cache Implementation, you'll be directed to this page. And the page says, the following packages provide this implementation. And then you can see that there's a couple of implementations out there. For example, the Symfony/Symfony, which extends, or part of that is the Symfony/cache package. So that's also there. And then there's a Zen framework cache, and then there's a bunch of cache / blah 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 adapters. There's a APC adapter. There's a doctrine bridge. There's a a Laravel bridge. There's all kinds of adapters out there. Again, more adapters. And they all provide an implementation for the cache item pool interface and the cache item interface objects. And if we click on one, this is, for example, the cache/file system adapter, which uses Frank de Jonge's fly system. It says leak/fly system. It provides a PSR/cache implementation. So this provides an implementation for the interfaces inside the virtual package, inside the package that is defined by the virtual package PSR/cache implementation. So there's also a package called cache/integration tests, and that's super useful. I use it myself because I wanted to build my own implementation of a PSR-6 interface object, and I use this package to basically generate my PHP Unicode tests. So this is the only thing I had to write. This is pretty neat. I had to write my own pool integration test, and that had to extend some cache pool tests, and that is itself is a PHP unit test. So just by implementing this one method, I already had all my unit tests. And those unit tests basically make sure that your implementation complies with the actual implementation. So that means it checks if the array, if you have the getItems method, it should return an associative array with keys and items. And this basically checks all of that you actually comply with the PSR. So that's pretty neat. I should say thank you for that. There's a bunch of cache/ packages, and I love them. There's the taggable cache, which basically implements the tagging. There's the namespaced cache, hierarchical cache, prefixed cache, encryption cache. There's an array adapter, which is basically in memory. So you don't hit any backend, it's just in memory. There's the void adapter, which basically doesn't remember a thing. It basically has dementia. And then there's the chain adapter, which is super useful if you have multiple levels of caching. So in a processor, you have L2 caching, L3 caching, and this basically mimics that. So you have a local, super local cache, which might be limited in space, and you also have like a cheaper cache, but it's a little bit slower, and it's offsite. It might be on a different server. You can use chain adapter to chain different levels of caching. So if something is not found on the local cache, it will try to hit up the slower cache on a slower database or a slower backend, for example. I'm going to basically demonstrate all of these at the end of this presentation. So how do we upgrade from using our libraries and using our frameworks to using PSR-6? So for libraries, we have to wait for next major versions. This is basically a breaking change. If you have a geocoding library and you want to start using PSR-6, you want to move away from the old interfaces that you had and the old adapters that you had to move to the new PSR-6, to have a new caching decorator that uses PSR-6 caching. For frameworks, it's basically the same thing. Start using PSR-6 enabled libraries and then use adapters, more adapters, I know. More adapters to start using PSR-6 enabled libraries inside frameworks to use your same configured caching backends that you had in your framework. There's some frameworks that already adopted it. There's Symfony/Cache. I think version 3.0 was already PSR-6 enabled, or 3.1, I think. And then there's Cache/Illuminated adapter, which is an implementation for, or an adapter for Laravel. So you can already use Laravel with this simple adapter. You can use PSR-6 in Laravel. I created this, but I endorse the official or the one that's better maintained than my own one. So how is the adoption? So it has been finalized and accepted at the end of 2015. And if you go look at PSR/cache implementations, now we will see that not a lot of libraries depend on it. It's only 9, so that's pretty poor. Some say that the adoption is low because it's too complicated. It has the deferring, it has the repository and entity construct, and it's sometimes can be pretty hard to understand. So some people said, well, it's too hard, let's make something simpler. So some people in the PHP Fig came together and they said, well, let's start a working group to create a simpler cache. And they called it Simple Cache. It's finalized and accepted in December 2016, so only 1 year after the PSR-6 interfaces. And it's basically simpler. It only has one simple interface. And the interface is PSR Simple Cache Cache Interface. It has a couple of methods. Let's go to my editor. I should have it here. Simple cache source cache interface. The other things here are exceptions. So the cache interface has public function, a couple of functions. The first one is get. You get something, and then you immediately get the value. You don't get an item or something, you just immediately get the value. And you can also pass a default value if you want to. The second one is set, which sets a value with a key, value, and TTL. It's pretty simple. The third one is delete. Speaks for itself. Clear basically truncates the entire backend. And get multiple. It's kind of surprising to me because they wanted something simple. And if you want to have a simple interface, you just leave off everything that is implementable by using old methods in a for loop, for example. So get multiple is support for batching, basically. So you can get multiple values from a cache store. Again, this will return an associative array with the keys and the values. And then, if something is not found in this cache store, it will return a default value for that key. Oops. There's also set multiples, so you can set values by using an associative array. So you can use keys and values. You can set multiple values at the same time, and they all have the same TTL. Or you can delete multiple. And then there's one more method, which is has, which makes sure that you can differentiate between a null value or it's just not being set. Because if you have a null value and you store it, you basically don't know if you do cache get and it returns null, you basically have no idea whether it was set or you set it null. So to differentiate that, you need to do cache has. And that will return a boolean. And then you can use if-else structures to differentiate, to have a different path in your code. So you can set a value. You can also set like a null value, for example, to differentiate from null versus not found. So for example, DNS also has negative caching. So if a DNS server is looking up a name, like for example, conf 2018 phpserbia.rs, if that DNS name is not known, then the DNS server will remember that. It will cache that for a certain period of time. So when you look something up and it's not known, and then you register it, it might take some time to propagate, or for the negative cache to propagate. So if you want to store something that is a negative result, then you might want to store something other than null, because otherwise it's kind of confusing. There's also support for multiple actions, so you can set multiple, get multiple, or delete multiple. I already showed the code, so I don't have to do that anymore. The differences between PSR-6 and PSR-16 is that null values are kind of hard to spot, and there's no deferring. So you cannot say, well, for this cache item pool might not have an optimal way to store stuff in a batched way. You can only set multiple, and then it will do whatever it needs to. So there's no deferring. There's no saying, well, I want to save something deferred, and the cache item pool has no way to find the optimal strategy to batch stuff to the backend. Again, the same characters are reserved for future features. So let's do the same thing here. Practical, who uses it and how can I start using it? If you go to packages again, who's using it? There's a PSR/Simple Cache Implementation virtual package. If you click on that, there's a ton of packages that provide this. There's Symfony, which conveniently also provides this as an interface. And then there's Zend implementation and a bunch of others. This same package gives you a test for PSR-16 implementations too. So you can check that. You can check both your PSR-6 and PSR-16 cache item pools and simple cache implementations. The upgrade path is basically the same as PSR-6. You're just going to add more adapters. Adapters everywhere. Who's using it or who depends on it? There's only one right now, which is pretty poor. But that's basically because there's so many adapters out there. There's a ton of adapters. There's the simple cache bridge even, which bridges between PSR-6 and PSR-16. So technically, you could do this in Laravel. In Laravel, you can create an old style or the framework default style cache store. You can wrap that in a PSR-6 cache store, and then you can wrap that in a decorator to bridge it to PSR-16. So there's different ways to use the same cache store, but use different interfaces to hit it. So let's go to some code. I've got a bunch of examples here which all use, if I go to composer.json, they all use some kind of cache/package. So I have a bunch of examples ready here, and I'm going to show you the differences on what they do. So the first one is the difference between a void adapter and an array adapter. As I said, a void adapter basically has dementia. It forgets everything you store in it. So the void cache pool, you can get an item. You never create a new item yourself. You first ask the pool to get the item object. It might be null or it might be not set. But then you set the value, say expires after 1 hour, then you save it. And then I'm going to print whatever is in there. So I'm going to print for this cache pool, I'm going to print whether the value is set and what the value is. So PHP 1 void or array. Does the pool have item foo? No. That's pretty funny because we asked it to store it, but it has dementia, so that's normal. This is one of the things you can use locally to develop your application. It just set the void adapter instead of a real Redis or Memcache adapter, and this way you ensure that rule number 1 of caching is not broken. Your app should still work if your caching layer fails. If your caching layer has dementia, your app should still work. So the second example is basically the exact same code, but we use an in-memory or array cache pool. And this array cache pool will remember it for the length of your PHP process. So if you have a separate user coming in, and that's a separate request, it's going to have a separate memory pool. So it's not going to remember for multiple consecutive incoming requests, but for this call, it will remember it. I hope. So if you do PHP void or array, and then the second example, does the pool have item foo? Yes. What's the value? Bar. So it remembers it, but not multiple times. Not for the next incoming request. So the next feature I want to demonstrate is tagging. We can add some tags to some items, and then we can ask the cache item pool to delete all items for that tag. So we have multiple items. We have foo1 and foo2. We're storing all of them. And we're setting a tag on foo1, and we're setting a different tag on foo2. So category 1 has a foo1 item, and category 2 has a foo2 item. We're going to save them deferred, and we're going to commit it. And then we're going to print the values. We're going to invalidate category 1. So basically, foo1 should be forgotten, and foo2 should still be there. And then we're going to print the same thing again. PHP2 tagging on index. So does the pool have item foo1? Yes, the value is bar. And the tags are category 1. Does the pool have foo2? Yes. What is the value? Key cux, whatever, how you want to pronounce that. And the tags are category 2. We can add multiple categories as well. It's an array. And then we're going to ask the cache item pool to invalidate or drop or forget all the items which are tagged category 1. And then we're going to print the same thing. Does the pool have item foo1? Nope. Does the pool have item foo2? Yes. And then it's going to print the exact same result. So that's tagging. So you can tag multiple items, and you can reuse the same category item for items with different keys, or you can set multiple tags on the same key. So if you go back here, you can basically say, let's also add category 1 here. So right now, if we run this again, both foo1 and foo2 should be forgotten. Does pool have item foo1? Nope. Does pool have item foo2? Nope. Foo2. So let's go and check out hierarchy. So hierarchy works with multi-level keys. And the keys basically allow you to say, well, everything below this key should be forgotten. We basically have an array cache pool, but the array cache pool conveniently implements the hierarchical pool interface. So if you go to the implementation, we can see that this uses a trait which adds this feature to this cache item pool. So this array cache pool already is implemented with this feature. So we can get an item user's foo. Foo could be the username or the user ID. And then we are going to set the value to bar and save it. We are going to do the same thing with products. So we have a different product also with the ID foo. We're going to set the value, store it, and everything should be good. Then we're going to print the values, and it's going to say, well, user's foo is Baz, and I think products foo is also, user's foo is bar, and the other one is Baz. That's just basically what it's going to print. And then we can purge everything under users, but it's not going to purge anything under products. So we can say delete item, pipe symbol. This is an important step. The pipe symbol has to come first to be able to differentiate between hierarchical keys or normal level keys. And then we say, well, everything under users should be deleted. And then we're going to print it again, and we're going to see that users foo is no longer there, and products foo is. PHP 3. So let me clear this again. Does the pool have item users foo? Yes, the value is bar. Does it have products foo? Yes, the value is Baz. And then we're going to purge everything under users, and it's going to say, well, users foo does no longer exist, but products foo still has the value for foo, and the value is Baz. So that's basically it. It's super simple. The next example is namespacing versus prefixing. The first time I read about this, I was like, namespacing is basically prefixing something, right? So it should still work. But there's a small difference between namespacing and prefixing. So let's show you. So we have an original pool, which is the base pool. And we're going to create a new pool, cache item pool, for a geocoding library. So everything for the geocoding library, we want to set this in the cache. We want to store this in the cache. But we don't want to mix that with other libraries storing stuff in the cache. So we are going to use a namespaced pool. And the namespaced pool basically starts with, every key is going to start with geocoding. So in the background, everything is going to be stored with geocoding as a prefix. And we can control that. That's a controlled namespace, and we're going to use that for the geocoding library. So we are going to store something called foo in the original pool. So this is like a normal level item. We're going to set it to bash, store it, set a TTL on it, everything, blah, blah, blah. And then we're going to use the geocoding pool, which has some kind of prefix. And using this prefix, we can use the same item key. So we can set foo again. This is the same key as we used before. And we set a different value, set the TTL, and store it. And then if we print it, we're going to say, well, print the values for this pool and for the other pool, and both use the key foo. And we're going to see that they have different values. That's because the geocoding pool has a namespaced set of keys and values. Even though right here we don't see anything with geocoding, we don't see the namespace, we don't see the prefix, but it's stored in a separate container. And then we can use the geocoding pool to clear everything that has to do with geocoding. And this will preserve everything that's stored in a global namespace or in a different namespace. So we are going to say geocoding pool clear everything for your namespace. We're going to print foo again for both namespaces, the global namespace and the geocoding namespace. We're going to see that for the original namespace, for the global namespace, foo is still there. PHP for namespaced first item. So first we're storing foo twice on the global namespace and on the geocoding namespace. On the global namespace, the value was bar. So right here, bar. And on the geocoding namespace, the value was bash. And then we're going to clear the geocoding namespace and do the same, print the same result. Does the pool have item foo? Yes. The value is bar. Does the geocoding pool have item foo? Nope, because we cleared it. And then the difference between namespacing and prefixing is basically that if you clear the pool with prefixing, you're basically clearing everything. There's no namespacing. You cannot clear a certain part of your subset of items. So we're going to create an original pool, and we're going to create a wrapped prefixed cache pool. And the prefixed cache pool has a prefix acme. So this basically means that you can use, you can set multiple items. You can set foo on the original pool, and you can set foo on the prefixed pool. And they're going to be, yes, they're going to be different. And then we can save those and print both of these. And then when we clear the acme prefixed cache, there's a small catch there. We're basically caching everything. So both for the original pool and the prefix pool, the value is going to be erased. Let's run this. So does the pool have item foo? Yes, the value is bar. Does the pool have item foo? Yes, the value is bash. Let me do something crazy here. Echo. Don't use echo, please. Original pool, get item foo, get key. I want to see what the key of the value is. The key of the item is. I'm going to do the same thing here, but for prefixed pool. I think, yep, there we go. So the key of the item is different here. So there's going to be foo and acme foo. And then when we clear it for any pool, we're basically clearing everything for all of the pools. So that's a little bit of a catch there. You can use prefixing, but that's going to be global. So The next adapter I want to show you is the chained adapter. So the chained adapter is something you can use to implement multi-level caching. I'm going to have a local one and a remote one, but they're basically both memory adapters. It doesn't matter. And then I'm going to chain them all in a cache pool chain. I'm going to say local first and then remote. I'm going to store something in the pool, the global pool, which is the wrapped pool. I'm going to store something and say, well, set foo to bar and set a TTL and save it. Then we can print it from both the local and the remote, and both of them will have the cache item foo stored. When we remove the item from the local pool, we can say local delete foo, and we print whether the local pool has foo or not. It's going to say no. But when we use the wrapped, the multi-level caching pool, if we ask that for foo, it's going to look up locally first. It's going to say, oh, it's not here. And then it's going to try and find it in one of the remotes, and then it's going to say, oh, it's there. So we can duplicate that in the local one. So it's going to say, yes, globally we have it in some of our levels of caching, and we're going to duplicate that to the more local caching layers as well. So if we do local pool, local, global, local, first it's going to say no, then yes, we found it globally, and then if we try to find it locally again, it's going to say yes, we have it now. So PHP, I think we're at 5, chained. So first it's going to say, yes, it's locally, yes, it's remote. We stored it globally, and it's stored on both levels. Then we're going to remove the item from the local pool only. And then locally, we're going to say, nope, it's not here. Globally, we still have it, because it's stored in a remote location. And the value is bar. And then when we query the local cache again, it's going to be duplicated from the remote one. It's going to say, yes, we have it again, and the value is bar. You're right on time. So I have 2 more examples here. The first one is encryption. We can use an encryption adapter to encrypt all the values. So we are going to create a pool, the original pool, and we're going to wrap it with a encrypted pool. And your encrypted pool will encrypt and decrypt all values. So when we store something with foo, we set the value to bar, we save it, and we print the original value without the decryption, and we're going to print the decrypted value with the encrypted pool. That's pretty hard to pronounce. Clear. PHP-6 encryption. Show me. So when we inspect the unencrypted pool, we're going to find a value that is pretty weird, because that's decrypted. But when we use the encrypted pool, we get an automatically decrypted value from the cache item pool. That is bar. 1 minute. Okay. One last thing, adapters. More adapters. So we started out with having too many adapters, and now we have even more adapters. That's cool. And this is the PSR-16 adapter. So the PSR simple cache bridge provided by the cache people. We can basically use a PSR-6 cache item pool, wrap it with a PSR-6 adapter, or bridge, whatever you want to call it, and we can use that interface to set a value. Cache, set food, and the value should be bar. And then we can use the PSR-6 cache item pool to find out whether something is stored or not. So if we run this, PHP-7, simple cache, there we have it. Something is stored using the PSR-16 implementation, or the PSR-16 interface, and it's basically stored in a PSR-6 interfaced adapter. So that's cool. Let's wrap it up real quick here. We started with an introduction. What is caching? What is rule number 1? Your app should work when your caching fails. Good. That's rule number 1. The rest you can forget. It's fine. And then we talked about caching before 2015. We talked about PSR-6, which is the repository entity model. So you can have items. You should always get the item from the pool first. The item can be empty, could be not set, but you will always get an item object, which has an immutable key. So it's an entity with an identity. And then we have PSR-16, which is simple cache, and you can set and get stuff on a simple cache interface. Thank you.
Ladies and gentlemen, Hannes van de Vreken. Do we have any questions from the audience? One question?
One, two.
2 questions. Whoa, just wait a second, wait up for the mic.
Hi.
Are there any rules about time to live limitation for any cached items?
That's a question that is different for everyone. You can set the TTL to a very long time and use cache busting. That's one option. Or you can set the TTL too short and have too many hits that are returning false. So it's somewhere in the middle.
Yeah, thank you.
The other question?
Dame i gospodo, kratko podsjećanje, tačno u 12 časova, Track A svoje predavanje održat će Kristof Willemsen, Track B Branislav Bujišić. Ukoliko želite da prisustvujete nekom od ovih predavanja, a da to ne radite sa middle tracka, bilo bi dobro da se sada uputite u jednu od sala. Ladies and gentlemen, short notice, Track A, Kristof Willemsen, sharp 12 o'clock. Sharp 12 o'clock, Track B, Branislav Bujišić. If you want to attend any of these lectures, now is the good time to go to Track A or Track B, or stay in the middle track and get your set of headphones. Thank you.
That wasn't my voice. Okay, we have a second question.
Anyone who still has questions, I have 30 minutes after this talk, so come up to me and... Yes?
Hi, thank you for the talk.
So
cache is still monster, which eat victims which need to regenerate the cache. Why PSR is not defining something for that, let's say, to generate it before expiration coming?
Sorry, I didn't catch the question.
Let's say we still have the victims, victim users, which need to regenerate the cache. Why PSRs still not defining something for regenerate the cache before it expires?
Basically, when you define an interface, you want to define something that works for all implementations. And if you enforce that to be part of the interface, then every implementation should have that. So that's, it's a trade-off between having too much in your interface or having too little. So that's one of the trade-offs they had to make, and that had to be sacrificed. You can use some kind of adapters for that. There's different ways to add that anyway.
Okay.
If you have any more questions, you can come up.
Any more questions from Hannes? Quick question, just a second. Yeah, we can hear you, but not everybody else.
I can repeat it.
Yeah, you can repeat the question.
Hierarchy? Yeah. Oh yeah, the TTLs can be different for every item. Yeah, even if you have a more global cache item or a key that you want to have subkeys for, then you can set different TTLs for the subkeys. That's fine. Yeah.
Okay, ladies and gentlemen, Hannes van de Vreken. Thank you once again. Okay, in a few minutes, 12 o'clock sharp. Kristof Willemsen is going to be here, and as you heard from my colleague Branislav Bujišić on Track B. So make a decision, and we're going to start in 5 minutes. Thank you.